Okay, problem 2 is exactly the same as problem 1, except that in problem 1 we're asking for this tension T right here, and in problem 2 we're asking this for this force F of the shoulder on the arm. And so to recap, you know, we're going to do a couple of different things. We're going to balance forces. And so the force, the components of the forces, we're going to balance. So all the vertical forces are going to have to add to 0. All the horizontal forces are also going to have to add to 0. And then the torques, which if we take the shoulder as the pivot point, which is very natural to do and eliminates the unknown F, the torques have to add to 0. And the torques are a counterclockwise or positive torque due to the deltoid muscle, and a clockwise or negative torque due to the weight of the arm. And so that gets us, as in problem 1, that gets us T almost for free. And once we have T, then we need to go to look at, okay, what are the sum of the forces going to do for us? Because the sum of the forces are going to give us F, right? So we have T from the first problem where we know what T is now. We have Fx minus Tx has to be 0. Since those are the only horizontal forces, you know, they're pointed in opposite directions, they have to end up being 0. And so Fx is Tx, and Tx is just T cosine theta. So we stick in our value for T into this equation, and we've got Fx is the weight of the arm times cosine over sine of L2 over L1. You can call that the cotangent if you want, but hey, we're not going to worry about it. Now, Fy, right? Fy is in this equation where if you look at the vertical forces, Ty, minus the downward forces, Fy and W, those have to all be 0. And so Fy is Ty minus W. Again, we know Ty is just T sine theta, which ends up being W L2 over L1 minus W. And I rearranged a little bit because it's prettier this way. And that's just me, right? Um, a little prettier this way. Why is it prettier this way? Because WL2 over L1 is a quantity that we have again here. And so that onto 1 minus L1 over L2, and this is just the ratio of lengths. This number is going to be less than 1. And that's it for homework problem number 2. Good luck with that.